This video is on circle problems that relate to Pythagoras' theorem. First of all, we're going to look at angle in a semicircle. Now, the angle in a semicircle is at a right angle no matter where C is placed in the circle. So if you look at this diagram here, the line AB goes through the centre of the circle here, and then whatever other point we choose around the circle, when we join it all together to make a triangle, this angle here will always be a right angle. Let's just do an example. A circle has a diameter xy of length 13 centimetres. Z is a point on the circle such that xz is 5 centimetres. Find the length yz. So I'm going to start by drawing a circle. And we know that xy is the diameter. So just right across the middle, I'm going to draw a line there. Call that xy. And we know that length is 13, and that's going through the centre. Z is a point on the circle such that xz is 5 centimetres. So I'm going to just say that z is here, and that is 5 centimetres between x and z. And then we can make the rest of our triangle because we want to find the length of yz, which is this line here. Then I'm just going to call that x. So if we see here now we have a right angle triangle, that point z is where the right angle is. And then from here we can just use our Pythag. So I have c squared equals a squared plus b squared. C squared is always the hypotenuse, which is opposite the right angle. In this triangle, that will be the 13. We'll have 13 squared equals. The a and the b, remember, can be either. It's just the other two sides, so we'll have x squared plus 5 squared. And then we can just solve this. 169 equals x squared plus 25. Minus the 25 to the other side. And we'll end up with 144 equals x squared. And we can solve that by square rooting both sides, and we'll end up with x equal to 12 centimetres. Next part of a circle we're going to look at is a chord. Now, when we draw a line from the centre of the circle at right angles to a chord, then it bisects a chord. If we just look at this diagram here, the chord is this whole line here. I'm just going to go over it in purple. That is the chord. It goes from one part of the circle to the other part of the circle, just a straight line across. We call that a chord. And when we draw a line from the centre of the circle to the chord, straight down to the middle, then that bisects the chord, which means it splits it exactly halfway, as it's right in the middle. And then we create two little right angle triangles here. Example 2. A circle with a radius 8 centimetres has a chord of length 10 centimetres. Find the shortest distance from the centre of the circle to the chord. I'm going to start with drawing another circle. So our chord is going to go straight across here. Remember, this can go anywhere on the circle. It doesn't have to be at the bottom. If you wanted to, you could do it, say, here. That would be absolutely fine. Now, that length is 10 centimetres. Now, from the centre, it says our radius is 8. So from the centre to the end of the chord here, that would be 8 centimetres, and also on the other side. That would also be 8 centimetres. Now it wants to find the shortest distance from the centre to the chord. The shortest distance will always be the straight line down from the centre to the chord, where it cuts the chord right in the middle. So we're wanting to find this length here. Just put a little X in there. So from there, we're going to have this little small triangle. I'm just going to draw the triangle here of one side from this chord. So we know the radius was 8. The side we're trying to find is this length here, x. Now this length at the bottom here is going to be 5. It's going to be half of the chord. Because that line bisects, remember, it is always halfway, which means the length of this bottom half of the triangle will be 5. And then we can use Pythag once again to figure out x. We have a formula c squared equals a squared plus b squared. Our hypotenuse is the 8 because it's opposite the right angle. 8 squared equals, remember the other two sides can go either way. We'll have x squared plus 5 squared. 64 equals x squared plus 25. Rearrange that and we'll get 39 equals x squared. Solve this. So we have the square root of 39 equals x. Now you can leave your answer like that, but as we are working with lengths, generally you'll find the solution will want it as a decimal. I'm going to round to 3 significant figures here because with the IB, that is how they generally would like their answers. And therefore, x will be equal to approximately 6.24 centimetres. Now, the last part of the circle problems is the tangent radius property. Now, a tangent to a circle and a radius at the point of contact meet at right angles. So a tangent is a line that we draw where it's going to not cross into the circle, it's going to touch the edge of the circle. So anything like this that we draw like that touches a circle at one point there, that's a tangent. So you can have lots of tangents around a circle. You could have one there, we could have one there. It's just a straight line that touches that circle just once on the outside, so it doesn't actually cross into the circle. Now when we do that on the centre, this point of contact here is where the right angle will be. Next example, a tangent of length 10 cm is drawn to a circle with radius 7 cm. How far is the centre of the circle from the end point of the tangent? Start by drawing a diagram. Here's my circle. So I'm going to draw my tangent. I'm going to draw it at the top to show you can draw it anywhere. Now this tangent is drawn and it's touching the circle at one point here. Now I'm going to draw a line from the tangent to my centre. We know that that is 7 centimetres. The tangent is 10. That 10 centimetres is going from the point where it touches a circle to the end. So this part of my tangent is not needed. So this length is 10. And we want to know the distance from the centre of the circle to the end of the tangent. So we're wanting to know this length here. And my right angle will be there. And then we can just use Pythag. So c squared equals a squared plus b squared. This time we are trying to find the hypotenuse, which is x. X squared equals the other two sides, 7 squared plus 10 squared will give us 49 plus 100. Therefore x squared equals 149. And then when we square root that, we'll end up with x being equal to 12.2 centimetres to 3 significant figures. And that's circle problems with Pythagoras.